We have our axis of symmetry at x equals 4. Not working. 1, 2, 3, 4. Thank you. All right, here's my axis of symmetry. Where was my vertex? 4, -7. 4, -7. Okay, so go down to -7. You know your vertex is going to sit on this line. Where was it crossing the y-axis? 9. Wow. Okay. Now I have one more point to find. What point is that? The mirror image of this right here. If this is 4 units away on the left, then I'm going to have a point 4 units away on the right. Okay? And so now all I have to do is connect the dots and make sure it's a U and not a V. And that's your final answer. I'm going to show you. Okay?
Now you know where x-axis.
Right now, I'm just worrying about this. Today, we're worrying about this. Tomorrow, we're going to throw in the x-intercepts. All right? Which we find by factoring. Okay, so if you're asked to graph this, I'm looking to see, is your axis of symmetry in the right spot? Is your vertex in the right spot? And are these 2 points in the right spot? And obviously, is it opening up? Okay? If it's opening down, I'm just going to stop. All right, here we go. There is a reason for these things, and they are used in real-life situations. The y-coordinate of our vertex tells us if there is a minimum or maximum value of the function. Now think of your y-axis. As you go up, you're getting bigger and bigger and bigger, right? As you go down, you're getting smaller and smaller and smaller. Get that down and then I'll show you. Y-coordinate of the vertex tells us if there is a minimum or maximum value, and it tells us what that minimum or maximum value is. Okay. If your parabola is opening up, the arrows go on forever into eternity. So are you ever gonna hit a high point? No, but do you hit a low point? Yes. The bottom of that curve, where this is on the y-axis, is your minimum value. So on the one we just did, when we were at -7, the minimum of that function was -7.
So the vertex and the minimum is the same thing?
The y-coordinate of the vertex and the minimum is the same thing. Okay? Because the y-coordinate is what you get when you plug into this function. If it's opening down, where this sits on the y-axis, however high you go, that's your maximum value. Okay, so if we're at +4 on the y-axis, our maximum value is 4. If this vertex was 5, 4, what's the maximum? 4. The y-coordinate, 4. Okay. Now, how is this used? Okay. We're an up-and-coming band. We want to put on a concert. Okay? Our little manager says, all right, I can't just blindly charge money and hope everybody's going to come because, number one, we have cost involved, and number two, we want to make money, right? Okay, maybe when you're just starting out, it's about entertaining. But when you're like, been there for a while, it's about making money. Okay, the following graph indicates what effect an increase in ticket price has on your overall income. All right? And the question is, where is our income maximized? At what ticket price do we make the most money? Okay. You don't have to write all this down, Nick. Okay. Here is a graph. This is a parabola, is it not? Okay. Your x-axis or your x value is the things that you have control over, things that you can change. You can determine how much you're going to charge for your tickets. This is ticket price in dollars. $10, $20, $30, $40, $50, $60, $70, $80, $90. Okay? The y-axis is your income that you don't control.
Miss Sally?
Yes, ma'am.
You said Kirsten Shufflin to Coach Johnson's office?
Okay.
Thank you.
Based on your ticket price, that affects your income. Okay, now let's look at this real quickly. Why do you think at a charge of $5, we're not making much money? It's not a whole lot of money, and there are costs involved, right? So we're not making much of a profit off of each ticket. Okay? We would need a whole bunch of people to come. Why do you think at, let's say, $63,
Price is too high.
Nobody wants to go.
nobody wants to pay that much? Okay? This is obviously not Van Halen. Because Van Halen charges $100 a ticket for like a top level seat. But anyway, okay. The way this is used is, where is the maximum income? On the y-axis, where do we make the most money? Here. Here we're making about, let's say, $87,000. Well, what's the ticket price at that location? 32, 33, 32.50. So now we know what we need to charge for our tickets. Okay? Now this income, this information, you can't just do this the first time you put on a concert because you don't have anything to go off of. This is an analysis that is made based on past concerts. What was the charge? How many people showed up? All right, because your income is based off of how many people buy the tickets, right? So that's what's involved here. Okay? Say we're going to do a fundraising project. Let's just say it's the drama club over here. Last year, pretend they charged $5 a ticket and 400 people came to the play. Okay? How much money is that? $5 times 400 people. $2,000. Okay, their income was $2,000. It's not their profit, but that was their income. Your profit is when you subtract your costs out of that. All right? This year, let's say they want to go to New York because they want to see a Broadway play. So they know they're going to need to make more money. Okay? Well, we can charge more money for the tickets. But what happens when you start charging more money?
Nobody wants to go.
People stop coming because there are some people who are not willing to pay that. So, we're going to estimate for each 50-cent increase in price, 10 less people will show up. Okay, so that means if we raise the price from $5 to $5.50, instead of 400, we'll have $3.90. If we raise the price from $5 to $6, instead of 400 people, there will be $3.80. Okay? All right, well, we're going to find out what is a function so that we can see where is our income maximized, and that's what we're going to charge. All right? How much should the tickets cost?